If you live to 90, you will spend 30 years asleep. 30 years of nothing. Eyes shut, body still. Awareness gone somewhere you can't describe. And every morning it comes back, and you have no idea where it was. You just stand up and start the day. We call this rest. But that word hides something strange, something nobody can fully explain. Sleep is the only thing your body refuses to skip. Skip food, you live for weeks. Skip water, 3 days. Skip sleep, and the damage starts within 48 hours. In the 1880s, a Russian researcher named Maria Manesina ran an experiment that nobody wanted to repeat. She kept newborn puppies awake. She didn't starve them. She just didn't let them sleep. They died in days, faster than the puppies she'd starved for comparison. When she opened their bodies, she found ruined organs, internal damage everywhere. The brain itself looked almost untouched. The destruction was in the gut, the blood, the heart. Something about being awake was tearing them apart. Decades later, the sleep researcher Alan Rechtschaffen put it bluntly. If sleep does not serve some absolutely vital function, then it is the biggest mistake evolution has ever made. Because from a survival angle, sleep is a disaster. You can't run, you can't fight, you can't even see. A lion sleeps. An antelope sleeps. Both are vulnerable. Both do it anyway. Every single night. Every animal that scientists have ever studied does some version of this. Elephants, worms, flies, even creatures you'd swear shouldn't need it. In 2017, a neurobiologist at Stanford named Ravi Nath looked at a jellyfish called Cassiopeia. It has no brain, it has almost no nervous system, it is barely a network of nerves draped on jelly. And every night, for about 8 hours, it stops moving. If you wake it up, it gets sluggish the next day. It looks for chances to fall back asleep. It needs to catch up. A creature without a brain, sleeping. Jellyfish have existed on Earth for over 600 million years, which means sleep is older than the brain, older than thoughts, older than memory. Whatever this is, it started before there was anyone to wonder about it. So what is your brain actually doing in there? For most of human history, the answer was a guess. People watched sleepers, saw something missing, and called it whatever fit their fears. A small death, a visit from the gods, a demon on the chest. The real answer needed a machine that could look inside. In 1953, in a basement lab at the University of Chicago, a graduate student named Eugene Azarinsky was watching a sleeping child through electrodes. The work was boring. He was supposed to track eye movements. Most of the night, the readings were flat. Then the machine went wild. Pins jumping, lines spiking. The boy's eyes were darting back and forth under his closed lids, fast, chaotic, and his brain was firing like he was wide awake. Azarinsky thought the equipment was broken. He reset it. The same thing happened. He woke the child. The child described a vivid dream. He ran the experiment again, and again, and again. Every time the eyes started moving, the dream started too. That wasn't a glitch. That was a second kind of sleep. Sleep is not one state, it is at least two. They cycle through your night, taking turns, doing completely different things to you. One is slow and deep. Your brain produces huge, slow waves, like swells rolling toward a shore. This is when you forget the world. The other one looks like you're awake. Your brain lights up, your eyes race, your dreams build whole worlds. But your body cannot move. A French scientist named Michel Jouvet figured out why. He worked with cats in the 60s. He removed a small piece of the brainstem in some of them, the piece responsible for paralysis during REM sleep. Then he watched them dream. The cats stood up while asleep. They stalked invisible prey. They arched their backs at things that weren't there. Their eyes were closed. Their dreams were running their bodies. That paralysis isn't a side effect. It's protection. Your brain freezes you on purpose every night so the dream stays inside. But this raises a question. Why dream at all? Matthew Walker, a sleep researcher at Berkeley, calls REM sleep an overnight therapy session. Your brain runs you through your worst memories, but with the chemistry of fear turned off. The amygdala stays active. The stress hormones do not. You feel the memory again, but in a softer version. And by morning, the sharp edge of it is gone. The memory stays. The pain doesn't. This is why people say things look better in the morning. They're not just saying it. Your brain literally refiles them. People with PTSD often have broken REM sleep. The therapy session keeps failing. The memory never softens. They wake up and yesterday still cuts. So sleep handles your memories, your emotions, your reactions. But there's another layer to this, the deepest one, and it took almost a century to find. In 2013, a neuroscientist named Micah Nedergaard at the University of Rochester was studying how the brain handles its own garbage. Because your brain produces a lot of garbage every day. The cells in your head burn through energy. They leave behind broken proteins, fragments, sticky molecules that, if they pile up, start clogging the wiring between your neurons. One of those proteins is called beta amyloid. You may have heard of it. It is the protein that clumps inside the brains of Alzheimer's patients. For decades, nobody could explain how a healthy brain cleared this stuff out. The rest of the body has a drainage system. The brain seemed to have nothing. Nedergaard found that it has something. She found that when you fall asleep, the cells in your brain physically shrink. The space between them opens up, almost doubles in size, and spinal fluid begins to flood through. Imagine the streets of a city. During the day, packed with cars. At night, water rushing through them, washing the day away. That is what is happening inside your skull right now, every night. She called it the glymphatic system, and it almost only runs while you sleep. Your awake brain cannot afford to do this. The cleaning would jam the signals. So evolution made a choice: run by day, clean by night, and split the two so completely that one cannot survive without the other. This is what makes the next part terrifying. Researchers have measured beta amyloid in people kept awake for a single night. The levels go up, not dangerously in one night, but measurably. Now stretch that across years, decades of short nights, decades of half cleaning. The plaques start forming 20, sometimes 30 years before any symptom shows up, which means the way you sleep in your 40s may quietly decide whether you recognize your own children at 70. Most people will never know it was happening. And if you doubt how serious this is, look at what happens when sleep gets cut entirely. In 1964, a teenager in San Diego named Randy Gardner stayed awake for 11 days. By day 4, he couldn't do simple math. By day 7, he was hallucinating. By day 11, he was a body shaped like a person, but the person inside was almost gone. He recovered, but only because someone finally let him sleep. Rats kept awake forever die in 2 or 3 weeks. Their organs fail. Their immune systems collapse. Their bodies eat themselves. And science still cannot give one clean answer for why. Memory consolidation explains part of it. Emotional processing explains part of it. The glymphatic flush explains part of it. None of them alone explains all of it. Sleep is not one thing. It is a stack of solutions evolution kept piling on top of each other for 600 million years. Memory, emotion, cleaning, repair. Something we haven't named yet. We sleep because all of life sleeps, and we are alive. So those 30 years you'll spend unconscious. They are not empty. They are not lost. They are not the price of being alive. They're what makes the other 60 actually yours. Tonight, when you close your eyes, something quiet and ancient will start. Your cells will shrink. Your memories will move. Your fears will be refiled. Your skull will be washed clean. You'll think nothing is happening. Everything is happening. And that's why you wake up, still you.